Okay, so the other parts of this switch here, AC and DC, that tells you what type of coupling you have to the circuit. And there's an AC coupling and DC coupling. Basically, what that means is there's a capacitor in the circuit or not. Now, we've talked about capacitors in terms of DC circuits. We haven't yet gotten to alternating current circuits, but one of the functions of a capacitor in an AC circuit is that it will block DC. We know that when you have a direct current capacitor circuit, the capacitor charges and it becomes maximally charged, and then the current stops flowing. And so that blocks the flow of current. But with an alternating current, the voltage on the plates is switching back and forth, and so the current doesn't go forward. So here's what the purpose of that is. If I have a signal, the signal might really be putting out that many volts DC. So that would be, depending on the scale here, I might have 2 volts DC and then plus whatever my alternating signal is. If I have it set to DC, it's going to pass everything because there's no capacitor built in. And so I'll get the raw signal. The reason I might not want that is that DC isn't helpful, and it's just, causing problems in terms of heating up the circuit elements inside. So if we look at the AC circuit, that's going to pass. Now, the reason it's elevated here is because I actually simulated that by moving the position. I don't have it's called a DC offset here. I don't actually have a DC offset coming out of my function generator, or at least not a big one. So this is pretty well grounded. This is pretty well grounded. But if I had a signal that had a bias, I could flip the switch and either show what the bias is or filter it out. Cut.